Okay, so today we're going to cover Chapter 2, Section 4. At the beginning part of the notes, we're just going to talk about some basic parent functions. And there's going to be 5 of them. So we're going to look at the absolute value parent function, the square root, quadratic, cubic, and cube root. Now, what you need to do is memorize the shape that these parent functions take on. So as you can see, the absolute value function takes on the shape of a V when you graph it. So what we're going to do is, in tomorrow's homework, we're going to be taking our parent functions, and then you're going to be graphing another function that's going to involve shifts. So instead of making a whole table of values for each shifted graph, it's going to be easier if you memorize the parent and then from there apply shifts. Today we're not shifting. Today we're just going to take a look at what each parent function looks like. So for the absolute value function, what I recommend you do is, for all of these graphs, memorize the location of these 3 ordered pairs. So if I do a quick little table and I plug in -1, 0, and 1 for x, remember f of x is just really saying y equals. So if I put here y equals so I can show the work of me plugging it in, and then the answer I get, I'm going to turn that into a coordinate or an ordered pair. So if I plug in -1 and I absolute value it, I get 1. And that's what my y equals. So then I would graph the ordered pair, -1, +1. And then if I plug in a 0 for the into the absolute value, I would graph the ordered pair 0, 0. Plug in a 1, I get 1, so 1, 1. So then if I take these 3 points and I put them over here, and then when I connect them, I need to remember that when I connect them, I'm making a V shape. Now tomorrow what we'll do is we're going to apply shifts. We're either going to move this graph up or down or left or right, maybe even make it skinnier or fatter. So this is what you should do, is memorize the location of these 3 points, and then if we have to shift, we just move these 3 ordered pairs. Now let's go ahead and identify the domain range, increasing and decreasing, of this absolute value function. So here, my domain, now just like in WebAssign last night, if there weren't closed or open circles on the ends of the lines, you knew that it meant that it was going forever. So my domain here, this V, is eventually going to get bigger and bigger and bigger, so it's going to cover the entire x-axis, so it goes from -infinity to +infinity. It's all real numbers. The range, however, again, remember when you go from bottom to top, the first value of y that I encounter is right here at the x-axis. So the lowest value is 0, but then it goes to infinity. And the 0 gets a bracket because it's a solid line here. I know there's not a closed circle, but when it's a solid line, that would be a bracket. The only time it's a parentheses is if it's an open circle or if it's around the infinity. Now, this graph actually has an increasing piece and a decreasing piece. So it's actually increasing over here from 0 to infinity, and it decreases from -infinity to 0. So this is the decreasing portion. Looks like a negative slope. This would be the increasing. Now, a lot of times when you're trying to separate increasing, decreasing, and constant, a lot of times you can look right at your domain and pull it from there, but here I got to break apart that all real numbers. So it's going to increase from 0 to infinity, so from here to here, and the decrease goes from the -infinity up to the 0. So increasing will be from 0 to infinity, and the decrease is from negative infinity to 0. All parentheses. If you put brackets on the test, I'm not going to mark it wrong, but this textbook and WebAssign's looking for parentheses. The constant DNE does not exist. The next parent function is the square root function. Remember, we do not want any imaginary solutions. So notice this graph is only going over here for positive x values. So when I go to make my little table here, instead of plugging in -1, I only want positive values, so I'm going to plug in 0, 1. Instead of plugging in 2, since I'm not using a calculator, I'm going to plug in a 4. These values you plug in can be whatever you want. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. So the order pairs that I would graph would be 0, 0, 1, 1, 4, 2. So we could put our little points here, 0. We could say 1, 1 might be around here, and then the 4, 2 might be around there. So as you can see, your domain is starting here at 0, and then it's going to infinity. So, yes.
Wait, never mind.
Same thing for the range. We don't want any imaginary numbers because remember, if we were to square root a negative number, we would get an I. So the range goes from bottom to top. So the range starts at 0 and goes to infinity. And this entire domain interval, the whole thing is increasing. So from 0 to infinity. These two do not exist. Nothing decreasing and nothing is constant in the square root graph. So the next parent function we're going to look at is the x squared graph, or the quadratic. So anytime you have an x squared in your equation, your graph is going to be a U-shape or an upside down U-shape. So for example, if it were a negative x squared, then it would be upside down U. So notice here, this would be eventually getting bigger and bigger, a bigger and bigger U. So the domain here is all real numbers. However, the range, it's the first point as I'm moving from the bottom to the top that I encounter is 0, and then it goes to the infinity. So the range is from 0 to infinity. This graph has an increasing part and a decreasing part. So over here is the increasing side, and over here is the decreasing side. So for the decreasing, it's decreasing from negative infinity, and then it stops here at 0. And then the increasing picks up at 0 and goes to infinity. So from 0
Do we
to...
have to make a chart for this one?
Oh yeah, we can. We'll go back and do that. Absolutely. Again, this one's going to be the same as the absolute value when we make the chart. So let's do that. Let's plug in -1, 0, and 1, x squared, and then the order pair we get. So when I plug in -1 and I square it, it turns positive. So -1, +1. When I plug in 0 and square it, I get 0. When I plug in 1 and square it, I get 1, 1. So the 3 points are here, here, and here. And again, remember this takes on a U shape. And then no constant, so it's dne. Function, it sort of like looks like this. I know it looks like it dips a little bit, but this is actually increasing over the entire interval. And both the domain and the range for the x cubed function are all real numbers. So all real numbers, and the range is also all real numbers, and it increases over the entire interval. Both of these are dne. You had one of these in the homework last night. It looked like it was constant, but honestly it's just hovering over that axis. If it were a negative x cubed, then it would be reversed. It would look like this. But it's actually increasing over the entire interval, or this one would be decreasing over the entire interval when it's a negative, and this should be an x cubed. And then the last parent is the cube root function. And it sort of looks like we're like taking and rotating our graph a little bit, like this one, and we rotate it around. So let's see it. So this is the x cubed. Oh, I can also do the table here. Let me do the table for the x cubed. So x cubed, xy. So if I plug in -1, 0, and 1, -1 cubed is -1. 0 cubed, 0, 0. 1 cubed, 1, 1. So over here, the points are here, here, and here. And again, you're going to memorize, you don't want to make a diagonal line. When you see an x cubed, you know you got to get a little wave to this thing. So when you go to graph the three order pairs, make it little curved. All right, let's try the cube root. Again, if I do a table of values, using those three numbers, -1, 0, and 1, -1, when I cube root it, I get -1. 0, when I cube root it, I get 0. And 1, when I cube root it, I get 1. So here, here, and here. And again, don't make a diagonal line. If you know you're graphing the cube root function, you need to add a little squiggle to it. So the domain here again, it eventually will go wider and longer. It'll be all real numbers. Same thing for the range. Even though it looks like it's only pointing left and right, it's actually slanting downward and upward a little bit. So both the domain and range for both the cube function and the cube root are both all real numbers. I don't know what happened here, this one erased. And then this one is also increasing over the entire interval. These two are dne. Now we're going to graph the parent, the piecewise. So we're going to use these parents tomorrow when we learn about the shifts. Today, when you're doing the piecewise homework, you really don't need to use these parents. However, when you're graphing the x squareds in the piecewise, just remember, don't make a straight diagonal line. Put a little U shape to it, or half of the U. All right, so I'm going to actually graph them both on the same graph. So I'm going to do the first one in blue and the second one in red. Now, we have options here. We can either, these are both linear functions. So again, remember, f of x is a fancy way of saying y equals. So I can either choose to do y equals 2x plus 3, put my first point on 3, use the slope, rise 2, run 1, and then make my line. However, notice I've got a restriction on where the graph should be located. It's got x is less than or equal to 1. So what I'm going to do is, if I were to just graph this using y equals mx plus b form, I could put my first point on positive 3, and then I would move my slope. Rise 2, run 1, and then I could do it this way. And normally you would connect this and make your line. However, we only want the line to be x's that are less than or equal to 1. So then what I need to do is go back and erase this part of the graph, because that's where x is bigger than 1. So this would be the graph of the blue if I just use y equals mx plus b. Let me erase the whole thing now, put it in blue. Now, the other way, if this confuses you about graphing it and then erasing it, what you can do instead is you can make a table. So this would go this way. Or you could say, okay, I don't want to do that. I want to do my own little table here, 2x plus 3, and then you'll get your x and your y. So here, I can only, in my table, plug in numbers that are 1 or less than 1. So like I could plug in 1 and 0, and that would be enough to make my line. If you want to plug in more to get more precision, you could plug in -1 because it's also less than 1. So then I would do the math. 2 times 1 plus 3, and then I get 5. And then I would graph the order pair 1, 5, which I already did. And then I'd plug in 0. 2 times 0 plus 3, I get 3. Oops, 3. So then I would graph the order pair 0, 3, which was my intercept, which I already did. And then if I plug in -1, I get -2 plus 3, and then I get +1. So -1, I guess I should put another column here, -1, +1. And then I would graph these 3 points and then also point it with an arrow only on the left side, because again, remember your stopping point was this, all numbers that are less than or equal to 1. And the reason why it's a solid circle is because it's got the less than or equal to. Now when I go to graph the red one, my very first point is going to be an open circle. So again, if you want to just do a quick table for the red one, x, y equals -x plus 4. And then again, get your order pair. And again, my values for x that I pick to plug in have to be greater than 1. Now, I always, though, need to plug in the number that was in the inequality. So I'm going to plug in 1, and I get 3. The order pair, when I graph 1, 3, I need to put it on the graph, but when I graph it, because it's got this symbol, it's an open circle. So an open circle on 1, 3. And now let me get another point, and then I'll point the arrow in the direction it needs to go. So let me pick a number that's bigger than 1. Doesn't matter what you choose. I could pick 2, or I could pick 3, anything bigger than 1. So -3 plus 4, and I get 1. So now I'm going to graph the order pair 3, 1. And then I'll point my line in that direction. If you were to have graphed this using y equals mx plus b, you would have started at 4. The slope is negative, so you'd go down 1 and over 1. So if you were to put your point here as a starting and then use that, you'd have to go back and erase those, because those were not solid circles on the one, and you didn't want to include x equals 0 because it's not in the interval. Yes?
Wait, why isn't the other red circle open?
So the only one that's going to be open is the starting point. And it's going to be whatever number is in here. And only that number for x gets the open circle. The rest of the line's all solid. Let's try number 2. I'm going to graph the first one in blue and the second one in red. So if I do the blue one, now again, you can do y equals mx plus b if you choose, or pick two numbers that satisfy this. One of the numbers has to be -4, and then the other one has to be less than -4. I'm going to do -6. So -1/2 x minus 6. So half of -4 is +2, minus 6 is -4. Half of -6 is +3, and then +3 minus 6 is -3. So the order pairs I'm going to graph are going to be -4, -4, -6, -3. Both of the beginning part, because it's got the less than or equal to -4, this first point is solid. So let me come over here to the graph. And at -4, -4, put my first point. And then I'm going to graph -6, -3. And then I'll point it off in this direction towards numbers that are less than -4. Now I'm going to do the other piece of the graph, and that's going to be for the right side, and that will be the red one. So again, if you prefer the little chart, x plus 5, I need to pick this time numbers that are -4 or bigger. So again, I'm going to put in -4, but when I plug in the -4, because it's this symbol, it's going to be an open circle when I graph it. And this gives me 1, so -4, 1. Then I can pick any random number I want that's bigger than -4, so I could plug in 0, and I get 0 plus 5, and I get 5. So then I would graph the ordered pair 0, 5. So open circle here at the -4, +1. Make that a little clearer. And then my next point is 0, 5. Connect them and point it off in the direction. So the left side of my graph comes from the first equation, and the right side of my graph comes from the second equation. So if there's no exponent on the x, you know it's just a straight line. Let's try number 3. Same thing. So I'll do this one in blue. And then x, 2 plus x. Notice this time my x values need to be 2 or less. So I'm going to plug in 0 and 2. So 2 plus 2, this gives me 4. So the ordered pair will be 2, 4. 2 plus 0, that gives me 2. So then I graph 0, 2. Let me put these on the graph. Now when I go to graph this first order pair, because it's got the less than or equal to, this is going to be closed or a solid circle. So at 2, 4, closed circle, 0, 2. If you want to plug in more numbers, you can, but at this point, just connect it and draw it. The arrow is pointing to the numbers that are less than 2. Yes?
So the first one always has to be like 2?
The number that's in the inequality.
Okay.
Okay, I'm going to do the same thing for the red one. I have to plug in 2, but this time when I plug in 2, it'll be an open circle on the 2 because it's just the greater than. So again, I'll plug in 2, and then I'm going to plug in a number that's bigger than 2, so I'll plug in 3. You can pick whatever you want. Now, notice this time it's an x squared, so when I connect my points, I need to make it kind of U-shaped, kind of curved. But it's only going to be part of the U. So if I do 2 squared minus 2, that's 4 minus 2, and I get 2. So I'm going to graph the ordered pair 2, 2.
Wait, Ms. Corey,
Yes.
I thought you couldn't have x be 2 because it has to be greater than.
So you have to plug in the 2, but when you graph it, it's open because it's the starting point. Good? Because technically I could plug in 2.5, but it wouldn't be on my graph if I plug in 3. You follow? So that's why you're always going to plug in the numbers that are here, but the difference will be if it's got this, if it's got a less than or equal to, if it's got a less than or equal to, or a greater than or equal to, then it's a closed circle on that number. But if it's this or this, it'll be an open circle. Always plug in the number in the inequality. Because I know nobody's going to want to plug in 2.5 or 1.5 or 1 1/4, any of those. So when I plug in 3, I get 3 squared minus 2, 9 minus 2, and I get the ordered pair 3, 7. So let me go ahead and graph these. Now again, this one is going to be an open circle. So 2, 2 open. And then 3, 7, it's almost here all the way off. So then again, don't make a diagonal line, sort of make it a little curved. It's the right side of the U. So add a little bend to it because it's an x squared graph. So just remember, whenever you're graphing an x squared or a negative x squared would look like this. Negative x squared would look like that. And then let's try the last. Let's say I didn't pay attention that my x's had to be greater than 2. Let's say I did a whole table and I did the x squared minus 2, and I also plugged in 1 and I plugged in 0. Then I would get 1 minus 2 and I'd get negative 1. Here I'd get 0 minus 2 and I'd get negative 2. So if I actually plug those in, then I would get order pairs over here. Let me do them in a different color. 1, negative 1, and it's going to be down here. And then 0, negative 2. I'm going to need to plug in more, but eventually what it's going to be is like that. If I actually didn't pay attention to this. So I'm not getting the whole U shape because of my restrictions on what I can plug in for X. Pretty good? All right, let's try the last one. And on your homework tonight, the last 2 questions actually have 3 pieces that you graph, just like this one. It's no different except for you're just going to have 3 things to do. So again, I can do the first one in blue. And again, you don't have to do the table, but I think by time you graph it using y equals mx plus b and then go back and erase, it's probably just as quick to plug in two numbers and get your line. So here I'm going to plug in -1, and I'm also going to plug in -3. You can choose whatever you want. The reason why I chose -3 is so that way when I multiply 2/3 times -3, it cancels. And this just becomes -2 plus 1. So I graph -3, -1. But when I plug in the -1 here, I get -2/3 plus 1, which gives me positive 1/3. So I would be graphing -1, comma 1/3. I need to plug in the -1 because that's what's in my inequality. So let me put these 2 points on my graph. And again, for the 1/3, just approximate the location. So I could put it probably around here. And then the -3, -1 will be about here. And then you would point it down. Now I'm going to do the middle one in red. Now notice the restriction here. I'm choosing numbers that are in between -1 and +1. So if I plug in -1 and I square it, I get 1 minus 1 and it's 0. So the order pair is -1, comma 0. Then when I plug in 0, square it, I get the order pair 0, -1. When I plug in 1, again I get 0. Now, for this one, remember your inequality was -1 is less than, x is less than or equal to 1. So for this value here, when x was -1, this one's going to be open. This one will be closed. And that's the only place I'm going to put my graph, because it only should fall in between -1 and +1. So it'll be an open circle over here on -1, 0, closed on the other two. And again, it's a parabola, so it should be like a little smiley face here. Now I'll do the last one. I'll do it in green. And again, I can do a little chart here. 3 minus x squared. And again, my numbers need to be 1 or bigger. So it doesn't matter what you plug in. I could plug in 1 and 2 or 1 and 3. So 3 minus 1 squared is going to be 2. If I plug in a 3, 3 minus 3 squared, 3 minus 9, and I get -6. So let me go ahead and graph those two. Now, this one right here, see how it's a greater than? So it's going to be open. So I'll go ahead and put an open circle on 1, 2. And then at 3, -6 would be down here. And again, it's going to have a curve to it because it's a parabola. And that is your piecewise.